In this lecture, we are going to look at the mechanism and the reaction of acid catalyzed hydration of alkene. Now, we have the step 1 here, the protonation of the double bond to form a carbocation. Now the question is, when alkenes are hydrated, what is the product of the reaction? It's going to form an alcohol. So let's say this is an alkene. Let's use an unsymmetrical alkene to make things easier. Now let's say you have C, double bond C, and then this is hydrogen, and then you have, let's say this is hydrogen. Let me use something like this, hydrogen and hydrogen, and then you have CH3, and then you have hydrogen. Okay, CH3, and then you have hydrogen. Now what is the name of this product or this reactant? You call this propene, or you can call it prop1N. Now if you react this with water, which is H2O, now recall that this mechanism is called, or what we have here is what we said is what? Acid catalyzed. We are going to write the mechanism of the reaction. But first of all, when you have something like this, H2O adds here, according to Markovnikov rule, this H and this one split to form OH. This hydrogen attacks the more substituted alkene, or the more substituted carbon. This carbon here is more substituted than this. Why? Because this carbon contains CH3 and hydrogen, while this one contains only 2 hydrogens. The one that has CH3 is more substituted. So this hydrogen come here. Are we getting it? And the OH will come here. Okay? So, the OH will come here, and then the hydrogen will come here. So the product of this reaction will be something like this: CH3, then we have C, here is what? OH, then you have hydrogen, then you have C, H, H, H. Why? Because this hydrogen came here. Okay, so that is the product of this reaction. Now, how does this procedure occur? What is the name of this product here? 1, 2, 3. This is propanol. Now, what is the mechanism of this reaction, or how does this reaction occur? We have the protonation of the double bond to form a carbocation. So we have something like this: CH3, right? Then we have C, hydrogen, C, hydrogen, and hydrogen, double bond, plus H2O. But what is protonating the double bond is what? An acid, hydronium ion. That is why we said the reaction is what? Acid catalyzed. Okay, so we have the hydronium ion. We can write it as something like this. Let me write it something like this. This O, H, right? This are the hydronium ion is positively charged. When I mean hydronium ion, what I'm talking about is something like this, something that probably most of you are used to, H3O plus. That's what I drew here like this, O. Okay, so we'll not get confused. H3O plus. Now what happens when this attacks here? Something will happen. Now the more substituted alkene, or the more substituted carbon, will carry the positive charge. So where would the positive charge be between this carbon and this carbon? Now the positive charge will be on this carbon. Do you know why? Because this carbon is more substituted. That means it has a lesser amount of hydrogen as compared to this carbon. This carbon has 2 hydrogen, this one has 1 hydrogen. So the one that has the fewest number of hydrogen, that's where the positive charge will be. Okay, so the product of this reaction is going to give us something like this. We have CH3, then we have C, hydrogen on top. This hydrogen will come here. No. We say this is where our positive charge will be, right? Then it means that the hydrogen will come to this carbon, right? So we have carbon, hydrogen, hydrogen, and hydrogen. Now this is what we call a carbocation. Okay, this is what we call a carbocation. So that is the first step of the reaction. Now the second step is nucleophilic attack by water forms a protonated alcohol. So the carbocation form is CH3, and we have something like this: CH3, CH, positive charge, then we have CH, then CHHH, which is CH3. Can decide to write it as CH, H, H. Now water will come and protonate this point. So water protonating it. Water is probably, if you know, in organic chemistry or in chemistry, it's usually written like this. This is structure of water. Then it has two lone pair. Are we getting it now? The two lone pairs of electrons will protonate this carbon here, right? Now, when the two lone pairs protonate this carbon, what we are we talking about protonated? No, it will nucleophilically attack. That means it's bringing in is what? Lone pairs of electrons, not protonates. It brings in its lone pairs of electrons. Now, as it's bringing in its lone pairs of electrons, that electrons will cancel this positive charge here. But oxygen is giving out electrons, so oxygen will become positively charged. So you now form something like this: CH3, CH. Then we have the oxygen positively charged, and then you have hydrogen and hydrogen. Okay, then you have C, of course, hydrogen, hydrogen, hydrogen. Now the last thing we are going to look at is, recall that when this one attacks here out, what happened? This hydrogen was added here. So as this hydrogen was added here, what happened is protonation. This negative charge here will kick in to form water, abi, which forms H2O. Now this H2O now will come back again. Are you getting it? The H2O now will come here again with its electron, right? And then what will happen to it? It will then attack or take this hydrogen from here. As it's taking the hydrogen from here, what will happen? This negative charge will kick in here. As negative charge is kicking in here, it neutralizes the what? Positive. So negative and positive neutralize each other. There will be no charge here. Are you getting what I'm trying to do here? This water molecule comes here, pick away this hydrogen. Now, if water molecule picks away hydrogen, what is it going to form? It means that there will now be 3 hydrogen, which is now going to form something like 3 H3O, then positive, which was what we started the reaction with, right? Then this one will kick in here. There's positive charge here before, but as this one is kicking in here, it becomes neutral, so there will be no charge there. So at the end of the day, what we are going to form is CH3, CH. Recall that there is no longer charge here, and then we'll have O, and then this hydrogen, which is what? OH, and then you have C. This and this is CH3, and this is the product of this reaction. So this is called 2-propanol. So you see that when propene is hydrogenated, hydrated by an alkene, if it hydrates, what am I saying? If propene is hydrated by water, it's going to form an alcohol, which is what? 2-propanol. Okay, and that is the mechanism of that reaction.